All right. Now let's look at how to write a recursive rule, or what is a recursive rule for a geometric sequence. We've already kind of used one. Flashback to recursive rules, back to 7.1 again. A recursive rule, if we scroll down, a recursive rule for a given sequence, I'm right here, gives the beginning term. So a recursive rule always has to tell you the term you start with, and then a recursive equation that defines the nth term by relating it to one or more of the previous terms. So if you notice here, this is what our recursive rule looked like for an arithmetic sequence. We had to know what the first term was. The first term is 50. And then to find every previous term, to find the next term, I take the previous term, which is f of n minus 1. So to find the fifth term, I would need to take f of 5 minus 1, the fourth term, and add 75. So since this is an arithmetic sequence, we add 75 each time. Now we're going to be doing this same thing, but for geometric sequences. Instead of adding the same thing each time, we're going to be multiplying by the same thing each time, but the same rules still hold true. For a recursive rule, you need to identify, first you need to define the first term. Okay, so you need to define the first term. So here I have a geometric sequence. First term is 50, second term is 100, so that looks like a multiply by 2 each time, times 2. 100 to 200 times 2. 200 to 400 times 2. Yep. So if I take 100 divided by 50, 200 divided by 100, and so forth. So it looks like here my common ratio is 2. Okay, so to write a recursive rule for this, first I need to define the first term. The first term, f of 1, is 50. Okay, and then write a rule. So we define the term, write a rule that relates the next term to previous terms. Terms or multiples. Sometimes it's more than one term. Okay, so but if my first term is 50, then to get to my next term, f of n, I take my previous term, f of n minus 1. Again, this is just my way of writing the previous term. And now instead of adding, we're going to multiply by the common ratio of 2. So this 2 here is that common ratio. So if I was looking, for example, if I wanted to find the 8th term, I would need to take f of 8 minus 1, which is f of 7, the 7th term, and multiply by 2. So all this is telling me is that to get to the 8th, to get to the term I want, I need to know the term directly in front of it. And I take that term and multiply it times 2. Okay, so there is our recursive rule. So this is recursive in that it applies to the number or numbers directly in front of it. Okay, so let's go ahead and let's practice writing a recursive rule. So here we have a sequence. So I'm going to start by creating a table for this, meaning this is my first term of 1,000. My second term is 500. My third term is 250. So this one looks like it's going down each time. What kind of sequence is it? What's it going down by? And this is where a calculator might come in handy. So it looks like it's not going down by the same amount each time, because from here to here, that goes down by 500. Here to here, it only goes down by 250. Okay, so to find that common ratio, I need to take a term and divide it by its previous, which is 0.5. Okay, what about the 250 divided by the 500? Also 0.5. So this is multiplying. To get from this term to this term, I'm multiplying by 0.5 or 1/2. I'm multiplying times 1/2 each time. So we have found that common ratio. Since it has a common ratio, what kind of sequence is it? It's geometric. Since it's geometric, it does not have a common difference. It has a common ratio of 1/2. And notice how I wrote it as a fraction. In this case, a decimal would be okay, 0.5, because I didn't round it. But if it needs rounded, write the fraction. Do not round the decimal. You want the exact common ratio. The common ratio is 0.5. Okay, so the next part, part B, let f of n be the value of the nth term of the sequence. What is f of 1? Well, do you see how me writing that table really helps? Because the first term is 1,000. So my f of 1 is 1,000. So write a recursive rule. Well, I'm kind of halfway there. For a recursive rule, I write the first term is 1,000. And then to get to the next term, I take the previous term, f of n minus 1, and multiply it times 1/2. Okay. Another way to write this is we often, since we're multiplying, is we'll write that 1/2 in front. Because when I write it in front like that, I don't really need the multiply symbol. It's just assumed that it's multiply. Okay, so your textbook will probably write it this way. F of n equals 1/2 times f of n minus 1. So 1/2 times the previous term. So now it says create a table to find the next 4 terms of the sequence. Well, we already have a table up here. We just need to extend it. We want to find the next 4 terms. We want to find term 5, 6, 7, and 8. I'm going to use my new calculator trick that I just learned. Okay, and we are going to, so basically, let's say 250, and we're multiplying it times 1/2, 0.5. That gives me the 125. Now, I'm not going to type in 125. I'm just going to type in times 0.5. That gives me 62.5 is the 5th term. Enter. 31.25 is the next term. Enter. 15, again, I'm not rounding, 0.625 is the next term. And the one after that is 7.8125. Don't round, write the whole thing out. Either that or write it in fractions. So there are my next 8 terms. I was able to very quickly find those. Excel would find them really quickly too, if you wanted to go ahead and use some of your Excel skills. So we found the next 4 terms of our sequence. They are right there. The 5th term, 6, 7, and 8.